Copyright, University of South Australia. This recording may contain third-party copyright material. Apart from any use permitted under the Copyright Act 1968, no part of this recording may be reproduced or rebroadcast by any means or process without the prior written permission of the University of South Australia and the copyright owners.
Hello and welcome to a video on the foot. So the first thing we're going to start with is just a quick refresher of the bones. So we know that in the foot we have the hind foot made up of the talus and calcaneus. Then we have the midfoot made up of the navicular, medial cuneiform, intermediate cuneiform, lateral cuneiform and the cuboid. And between these two bones we have a joint across here that we can see called the transverse tarsal joint. Now this transverse tarsal joint, what it does, it connects these two regions and transfers movements through down into the long part of the foot, or the forefoot, where the forefoot is made up of the 5 metatarsals and then the phalanges of the toes. Interesting to note that the big toe, or the hallux, has only got 2 phalanges, whereas the other 4 more lateral digits have 3 phalanges. So a proximal one here and a distal one here for the hallux, a proximal, intermediate and distal for the other digits. Some of the other joints that we have between the bones of the feet is this one here between the talus and calcaneus, which we call the subtalar joint, so below the talus. Now it's actually this one here where pronation and supination occur when compared to dorsiflexion and plantar flexion occurring at the ankle joint. So above we see the tibia and the fibula, as we know, articulating with the talus, and here is where we would get plantar flexion and dorsiflexion. But it's this one where we have the subtalar articulation, which would then allow us to go through those pronation and supination motions. Alright, so this one being the hinge joint, having only the single degree of freedom with the plantar flexion and dorsiflexion, and then this one down here, the subtalar, which has adduction, plantar flexion, dorsiflexion, and also inversion and eversion, where the calcaneus can move like this or like this, depending on the motion of the foot. Now what we can see here then as well is the space that exists between the medial malleolus and the calcaneus. So if we put our finger here like this, we can see that there's a space there, and this space we call the tarsal tunnel. So looking at this template here, what we can see is that we've got the calcaneus and the talus above, and the medial malleolus here, so those 3 bony structures that we see. So what we can do here is we can actually describe and talk about the tarsal tunnel. So we're going to use black for tendons, red for artery, green for nerve, and blue for veins. So we know that going through the tarsal tunnel, we have a few things. And we remember, if we make a mnemonic of this, we can go T, D, A, V, N, H, which if you've seen Harry Potter, stands for Tom, Draco, and Very Nervous Harry. Now these structures here all have their individual names, where T is tibialis anterior, D is flexor digitorum longus, A, V, and N, these are the neurovascular structures. So we have the posterior tibial artery, the posterior tibial vein, the tibial nerve, and the flexor hallucis longus tendon last. Now this is in order too, so we'd expect T to be here, then D, A, V, and H as we're coming down through the tarsal tunnel. So what is the tarsal tunnel? It's effectively a fibro-osseous tunnel which exists between the medial malleolus and the calcaneus. So we say fibro because there is a band of retinaculum which covers this, and osseous because of the bones. And it's a tunnel shape, so we have all of the structures passing through. So what we would have to start off with is, if we draw a line down like this, we then have the tibialis posterior tendon coming and attaching to the navicular tuberosity like this. The next one in series would be flexor digitorum longus, coming around as well, passing under the talus, going towards the toes, and we can't draw to the bottom of the foot, so what we can just do is we can just draw 4 lines representing that it would be going to the 4 lateral toes. So that's T and D, tibialis posterior, and flexor digitorum longus. Then we need our neurovascular structures, so the posterior tibial artery. Now as it comes down here, you can see that it's running behind the tibia, so therefore posterior tibial artery. Once it gets down into the foot, it actually divides and it changes into the medial and lateral plantar arteries. And this will be the same as the nerve and the vein to come. So up here, we call it the posterior tibial artery. And once it passes through the tarsal tunnel and goes onto the plantar aspect of the foot, it then divides into a medial and lateral plantar artery. Then we would have the vein, and the vein follows the same pattern, would come down along and divide into its medial and lateral plantar branches, and then the nerve too. The only difference is that the nerve above is just called the tibial nerve. So we would have the posterior tibial vein, because we also have an anterior tibial vein and an anterior tibial artery. But in the anterior compartment of the leg, it's our deep fibular nerve that innervates. So in the posterior compartment of the leg, coming onto the plantar aspect of the foot, it will just be the tibial nerve with no anterior or posterior, because of it's the fibular ones on the anterior side. Then finally, the last tendon that we'll have will be the flexor hallucis longus, and that would pass around the talus and would come down and go all the way to the distal phalange of the great toe. So flexor hallucis longus. Now over all of this, what we can do is we can draw in that retinaculum that we have. Alright, so putting that across there. Now these are the flexor muscles. So if they're the flexor muscles, then we would expect this retinaculum to be called the flexor retinaculum. They're completing our fibro-osseous tunnel. So having these arteries and the vein and the nerve go into the foot, this is how the plantar aspect of the foot gets its supply. So what we can do now is we can have a look at some of the intrinsic structures to the feet. So open up your prac book and you'll see these pages inside your book where you've got to label these plantar aspect images. So what we're going to do here is we're going to highlight some of the specific structures that you can see and talk about them, because these are the types of things that you might be quizzed on. So the first thing that we would see here is a large band of fascia. So the first thing that we see is we take away the skin, all right, and the subcutaneous fatty tissue, and then here we see this big thick band of fascia which is extending all the way to the toes from the calcaneus. So this large band of fascia extending from the calcaneus right through to the toes we call the plantar fascia, or the plantar aponeurosis, where the term aponeurosis is just describe broad flattened tendon, similar to that of fascia obviously. Now because it's most superficial, just underneath the skin, what it will do is it will create a layer of protection for the underlying structures. It gives origin or attachment to the muscles, which are in the next layer down, but its most important feature is that it supports the arch of your foot. And this is especially in the toe off phase in walking. So when we make contact with the ground, with the heel, the foot then comes and goes through its range of plantar flexion before it comes in contact with the ground. So here what we can see is we can see the medial longitudinal arch of the foot. Now the medial longitudinal arch is one that we want to maintain during walking. So we don't want this one to flatten. Now most of us have what we would call flat feet, where this arch drops a little bit when walking. That's normal because we need a bit of absorption when we go through that initial contact phase. But when we are taking the step away, you can see that if I did not have anything supporting the underside, that the foot would just open up like this. So having a big soft structure would not allow us to create force and propel ourselves from the ground in the toe-off phase. So when we're walking, what we get is we get extension of the toes as we're going through the phase of plantar flexion. Now we can see here that the fascia goes from the calcaneus through to the toes. So therefore, when we extend the toes, this space gets longer, and therefore the fascia pulls to increase the arch of the foot and create a rigid lever for toe off. So these are its primary functions. If we take that layer off and we go a bit deeper to have a look at the muscles in the feet, we wouldn't expect you to remember the origins or the insertions, just to be able to label them and tell us their function. Alright, so what we can see here in layer 1 is that there's a muscle coming around the outside towards the big toe. Now, if it's coming out towards the big toe, we know it's got to be called hallucis. Then here you can see one coming, and it has 4 individual tendons, which are then going out to the toes. So if we're going to the toes, yep, we're going to be called digitorum. And then another one on the lateral side here, which lends itself towards the pinky toe. And we know that the pinky toe is called digiti minimi. Now any muscle that is lending itself to the outside of a bone is going to pull it away from its midline. So this muscle will pull this way, therefore this muscle will pull this way, and then the one in the center here where it's aligned with the toes will create flexion of the toes. Now based on that, we can name these muscles quite easily. So the one going to the big toe, going to the outside, we will call abductor hallucis. Nice and straightforward. The next one in the center then, we will call flexor digitorum. Now here, this one, we just spoke about going through the tarsal tunnel will be flexor digitorum longus. So this one then must be flexor digitorum brevis. And then coming for the little toe, we would have abductor digiti minimi. So these are the muscles of the first layer of the foot. Layer 2 has muscles which primarily act upon the metatarsophalangeal joints. So what we can see here is we've got a muscle for the big toe, 4 individual little muscles in between the toes, and one for the pinky toe as well. From there, you can also see another big muscle here in the center attaching to this long tendon. So this whole layer is about creating flexion, alright, so helping the foot to create flexion. Now in layer 2 of the foot, what we then have is a muscle in the center here, and it's quadrangular in shape. So its name will be quadratus, and it's on the plantar aspect of the foot, so we call plantae. Then 4 individual muscles we'll talk about more in detail in the hand are these 4 attaching to the flexor digitorum longus tendon. And the flexor digitorum longus tendon, yes, you've recognized that it has come through the tarsal tunnel, which we can see on the plantar aspect of the foot as well. But these 4 muscles here, we call them the lumbricals. Layer 3, you can see a large 7-shaped muscle with 2 heads. Then a muscle here coming with the big toe, and another muscle here coming with the pinky toe. Now, if we talk about the midline of the foot, we know that the midline is the second toe. So you can see that this muscle comes across that midline. Therefore, it's going to try and pull the big toe inwards. So therefore, the name of it makes a bit of sense, and we would call it adductor hallucis. This one going to the big toe is directly underneath, so we'll create flexion. So we say flexor hallucis. Have we already had a longus? Yes, well done. Coming through the tarsal tunnel. So flexor hallucis brevis. And then we have one here over for the pinky toe, So flexor digiti minimi. Then the next group of muscles that we're going to have is the muscles of the interossei. So having a look at this picture here, what we can see is we've got the spaces between the metatarsals. Now, interossei, the word inter is between the bones, so is between, and ossei is of bone. Now your interossei, their function is for abduction and adduction of the toes, and then the same in your hand would be for your fingers. We just said that the midline of the foot will be the second toe. Alright, and we're going to have two groups of these muscles. We're going to have a dorsal group, so therefore on the top of the foot, and we're going to have a plantar group, therefore on the bottom side of the foot. Now there's going to be 4 of these dorsal ones and 3 of these plantar ones, whereby the dorsal ones will create abduction, motion away from this midline, and the plantar ones will create adduction, motion towards this midline. So what we can have a look at here then is if the second toe was to move this way, that would be moving away from the midline. And if it moves this way, then that will also be moving away from the midline. So your second toe can do either, just like your middle finger. So if we put the hand on the table like this, what we can see is that if we move our fingers into abduction, they are moving away from my middle finger. So this one moves away this way, these two move away that way. Then what I can actually do is I can move my middle finger this way. So see how it's abducted? It's gone in the same direction as these two fingers. And then here if I abduct my index finger, we can see that I can do that too. So it's abducted away. So imagine that the pen is the imaginary midline. I can take it this way, that's abduction, and I can take it that way, that's abduction. Try that with your second toe. Some people can do it, some people can't. So if we need muscles on either side then, in order to create abduction and adduction, they're going to attach here to the bases of the phalanges, these muscles, because they're going to create abduction and adduction at this joint. And this joint is called the metatarsophalangeal joint. That's because this is the metatarsal and this is the proximal phalange, so metatarsophalangeal. So the muscle will look like this, kind of like a tail feather, if you will. One there, one here, so that's 3, and one more, one here. So you can see that based on the side that the tendon attaches, this one will pull this way, and these 3 will pull that way. So therefore creating abduction of all of these toes. Your plantar interossei, they're going to create adduction. So what we need to do is we need to pull these 3 toes here towards the midline. So their muscle is going to look like this, more like a wing feather. See how all the muscles are on the side of the midline towards? So therefore they're going to pull in this way. Why doesn't the big toe have a palmar interossei? It's because if we remember from layer 3, it has its own adductor, so it doesn't need one. Now the function of all of these muscles, these plantar or intrinsic muscles of the foot, is not so much to create strong action. It's more for absorbing forces and then creating a rigid lever for when we're walking away. Alright, very good. Speak to you later.